Hello, everyone. Every time I get an intro like this, I feel like Bono, only shorter. But let's not talk about that right now. I want to start off with a feeling. Without any context, without knowing anything about this, have you ever felt like this? I see two people who are not asleep raising their hand. Yeah, okay. So you have felt this in your life. Now, I want to just say a tiny bit about this. This is the way I felt the first time I was running an app in production and trying to load balance it. So yeah, I felt pretty hopeless. I felt as if everything was burning around me, right? And I also obviously felt like a tiny dog with a hat. So yeah, very cute. But this is quite literally what I want to talk about for the next 20 minutes. I want to talk a bit about load balancing. And I want to talk about why it's important. I want to mention three main things: performance, uptime, and scalability. So I want to show you how to get the most of your Node.js apps without the fuss and the hassle. Why? Well, I'm actually deep down a very nice person. I want you to sleep well at night. I don't want you to take your stress with you home to your loved ones, to your family when you finish work. Because to be honest, I don't want that either. So moving on, I just want to say a bit about myself and why you should even listen to me about the topic here. First of all, my name is Adnan. I'm a developer evangelist. Yes, that is a thing. I do not do things with churches, no. I'm actually the guy they send to talk at conferences about cool stuff. So I'm basically a stand-up comedian for developers. Not a really good one, as I can see. Anyhow, I work at Sematext, and we're a company that does monitoring and logging, basically observability. And now you're wondering, why is this guy even talking about Node.js and load balancing? Well, I've been a JavaScript developer since before Bower was a thing. I don't think anybody even remembers what Bower is anymore, so I've been a JavaScript developer for a very long time. But more important than that, I'm a heavy, heavy DevOps advocate, meaning I really, really believe in cross-functional teams and engineers that are site reliability engineers, the guys that connect the dev and the ops. And that's a bit about, generally what I'll be talking about today. And now you're wondering, why is this guy talking about DevOps while he's an evangelist? Well, my transition into being an evangelist from being a developer or a SRE is because I've been teaching people to code for the last 4 years. And that's what I want to do today. I want to teach you something you can take away with you when you leave today, that you can use tomorrow in your projects. So I don't want to talk about random things or facts or whatever. I want to teach you something concrete you can use right away. Now, before we begin, I just want to take a few seconds to mention the agenda. So the next 20 minutes or so, 15, I'm going to be talking about three main things. And those things are, first, what is, meaning, what is DevOps? What is Linux? What is systemd? What are system processes? What is Docker? All of those fancy buzzwords, I'm going to break down so you know what is what. I'll also talk a bit about scaling up versus scaling out, so you know the differences between the two and how to use them. And of course, the most important thing is load balancing. I want to explain what that is and three main concepts and techniques you can use tomorrow. Now, moving on. I think personally that the human brain learns best through stories. And as far as I know, all of the important things I know from school has always been things that I've learned through interaction with my teachers and classmates and generally people I like. And this also has a personal connotation for me because when I was like 3 years old, my dad kept telling me bedtime stories, and those are freaking awesome. So if you're doing that to your kids, sweet, keep doing that, okay? But let's start with a story. This is an average Node.js developer, and his name is Joe, because, I don't know, Joe is a cool name, I guess. But he's an average developer like me, like you guys, if you do Node. And what has he done? He's created a Node.js app. But he's just made the app. he needs a way to show it to people. He needs a way to run it in production, meaning that he needs to learn a bit about Linux and DevOps and system processes and all of those funky things that the ops guys do, that us developers don't really have to know about, or actually, quite frankly, don't know about. But luckily, Joe, he likes to learn new things. He's a very, very, curious guy, I like to say. So what did he do? He did something I like to call baby steps. He breaks problems down into tiny steps he can do, that gives him the dopamine he needs to continue doing things. Now, the first thing he did was he started a tiny VM, tiny server he could use as his own. And then, quite frankly, he transferred all of his node files to that server. And then he started this app with something called systemd. Now, why systemd? Why systemd? Do we have anybody who knows what systemd is? Sweet, sweet. Oh, basically, systemd is a software that provides the building blocks for a Linux operating system, meaning that you can run and manage processes in the system with this software. Now, take a step back. This is exactly what Joe needs. He needs to run his app as a system process inside his virtual machine. Why? To recover automatically from crashes. By running it as a system process, he can start it and then make sure it doesn't crash and doesn't fail, because it can automatically restart. And this is exactly what Joe did. He created a file, and he specified, I want my Linux operating system to run my Node app and to make sure that it restarts if it fails. And this was eye-opening for Joe. He was like, oh my God, I can make sure it doesn't fail. And for a developer, a normal guy, an average developer, that was a huge thing. But, as all successful products, they grow and people scale up. They pay for bigger servers with bigger CPUs, with more memory, wanting more performance. But after a while, and after using a bigger server, Joe noticed this. He had a really jagged CPU graph showing that something wasn't quite right. And he didn't really know what was happening. He was very confused, to say the least. Now, what did he figure out? What did he figure out? Well, with running Node.js by default on multi-core CPUs, it doesn't really run that good. Because Node is single-threaded, it can only run one process per CPU thread or per CPU core. So by default, on a multi-core CPU, Node.js will never run on all cores, meaning you'll never have the full potential or the utilization of your processor. So what Joe needed to do was to figure out a way of running one process per CPU thread. Now, for an average dude, that was very, very complicated. What he had right now was all of his incoming traffic was being funneled into this one process running on one CPU. While everything else was just, being there, occupying space for no reason. So Joe got he went a bit crazy and almost said something like, oh, I should have just built this with PHP and it wouldn't have any problems whatsoever. That's just a random JavaScript developer bashing on PHP because that's what we do, I guess. Anyhow, he figured out he needed to scale up. He needed to scale up. But what? What to do? Why? How? So he went on Stack Overflow. I'm kidding, no. He figured out that he has something called load balancing. And load balancing is quite essentially, it's just a way to distribute traffic to all of your apps in a way that will make sure nothing fails or overloads your system. Okay, quite cool, quite cool. But how does he do this? Well, you can do this either with using the built-in cluster module in Node, that's built into the core Node as a package, whatever, or you can use it with Nginx. And you can use Nginx as a web server that's going to load balance all of your requests across your services. Sweet, awesome. Now, because the cluster module is built into Node.js, Joe thought, well, let's just start with what we have. I don't want to install anything new. Let's just use what we have. And he started out by using the cluster module. And what he figured out was that it makes it horribly, horribly easy to create worker processes. Meaning he could create processes that would run his app across all of his CPUs or CPU cores, with one master process that will distribute that traffic to all of the cores, to all of the worker processes. Now, this is what he ended up with. He ended up having a master process routing all of the incoming traffic to the worker processes. Sweet, now he has a way of distributing traffic all across his CPU cores. And the way he does this is super, super simple. He adds another file and specifies if it's the master process, spawn fork workers, spawn more worker nodes, or if it's a worker node, just run the app. Now, what happened after this was that he got a phone call from his coworker that's a front-end developer asking, yo, I need a web server to host some files. I need to put our React app on our server. This was not something Joe thought about, so he figured, okay, let's use Nginx. Now, Nginx, it's a hugely popular web server that's very, very performant, but it can also be a proxy and a load balancer, meaning that he can spin up multiple node processes on his virtual machine and then use Nginx as the proxy to load balance all of these incoming requests, meaning he doesn't need to have the cluster module, and he doesn't have to manage that master process. He can just throw that out, add Nginx to both have the web server, but also have the load balancing. Now, the way he did this was that he created another systemd file, but now, instead of using a standard one, he added this tiny @ symbol. And that made it possible to add variables into this systemd file. So he could specify which port he wanted this node service to run on, which is incredibly simple. He can just go ahead and run his system processes on whichever port he wants, to run as many as he wants, and this just makes life so simple. Configuring Nginx for load balancing means that you need to have an upstream for all of your processes and just proxy it. I mean, this is one of the simplest things I've seen in a long time. And after doing this, Joe figured out that his CPU usage started to even out. It was much more predictable. He didn't have the spikes, he didn't have the unpredictable behavior. That was awesome. Up until his product grew even more. Oh my God, now he can't just scale up anymore because his virtual machine is on fire, it's dying. He's like, it doesn't work anymore. So he has to figure out something new. He has to do something that is so popular today, and that's containers and orchestrators. Because it's 2019, he had to sit down, start learning about Docker and Kubernetes, and migrate his poorly structured monolith into poorly structured microservices, because let's be real, that's what everybody is doing nowadays. So yeah, that's what he did. But sadly for Joe, the steep learning curve you have with using Kubernetes and with using Docker, even though it's a household name right now, even though it's an industry standard, like, it's not easy. Like, it's really not easy to learn. And that's what Joe figured out. But after all of that hard learning, he figured out that there are 3 main things to load balancing with Kubernetes. And that is, you have to learn Docker. And with Docker, you package, run, and configure your containers.
Fine, okay, containers are isolated environments where you run your app. They will run the same across any Linux operating system. Sweet. The next one is Kubernetes. That's what you use to orchestrate these containers, to deploy them, and then to manage everything. Kubernetes makes it easy to have a cluster of nodes and a ton of resources in those nodes, including services, apps, containers, whatever, and it does all the heavy lifting for you. So you don't have to manage things you really don't need to. Lastly, you need to have a load balancer in front of your cluster to channel all the inbound traffic across all of those containers. So from a high-level perspective, it seems quite simple. You have the load balancer, and you can have as many virtual machines as you want and scale horizontally instead of scaling vertically. Is that, that's right? Yeah, that's right. Sweet. The way Joe did this was, first of all, he created a cluster. He needed to create a cluster, and after weeks of painstaking learning, he figured this was the shortest way to, through the command line, create a cluster on AWS. It was not fun. But after finally managing to do it, he figured that the next step was to deploy his app, his containers, into this cluster. And this is quite literally the simplest way to do it. You have a deployment resource where you define your container and your app, and you have a service resource where you define what to expose to the internet. So with having this, you can specify the service to be a load balancer, and then specify multiple replicas in your deployment, and Kubernetes will handle the load balancing for you. So you remember I mentioned the heavy lifting? This is the heavy lifting. You're not doing anything. Finally, you need to configure the ingress load balancer as well. And this is as simple as just installing the package and specifying which service to route traffic to. Lastly, why I think that this approach is so powerful is that with Kubernetes, you don't have to worry. You just use one dashboard to monitor everything you need, or the terminal, or whatever, and that's it. You just need to monitor your containers, their health, and Kubernetes will just, everything will work. Because as far as I know, the people that made that are much smarter than me. So I trust them more than myself. Now, lastly, I just want to wrap up and give you a verdict of everything I talked about, and that is quite literally this. Using the cluster module is amazing because it's built into Node. It's super simple to use, but you have some code edits which aren't that good. Using Nginx is the next step I'd personally like you to use, because you only have the configuration edits. You don't have any code edits whatsoever. So if you're adding it to an existing project, just slap in the configuration and you're ready to go. Also, it gives you a proxy and a web server and a load balancer in one. Lastly, if you have a huge project, use Kubernetes. If you do not, please don't. Just humble opinion, okay? Please don't. Just don't. But Kubernetes makes it super simple to scale out, meaning that you don't have to do anything special. You just kind of click on one command in the terminal and it just does it. Okay, but lastly, from the bottom of my heart, please do whatever you feel like doing. There is no silver bullet with this. You have a use case, you have a problem, use the hammer that's going to fix that problem. Don't use a bulldozer if you don't need it, okay? That's what I want to tell you today. That's what I want you to take home today. And in the end, why am I even talking about this? Why am I even talking about Joe? Well, yeah, Joe is actually me. I went through this. I kind of cried a lot in a corner until I learned how to do it right. And from my heart to you guys, please don't. Please don't. Yeah, and that's it for me today. Thank you for having me.
Hi.
Also,
thanks, Adnan. Okay, just before questions, I do see you. Just a short service announcement. After this talk, there will be a closing word, and I kindly invite you to stay over because I promise it will be fun and informative.
Am I doing the closing word as well?
Well, if you want, I don't know.
It was lovely having you today.
Questions?
There's
Thank
beer
you for a
afterwards.
great talk. What about Fargate?
I'm bad at seeing, so zoom in.
AWS Fargate instead of Kubernetes?
Fargate?
Yeah.
Sorry, I didn't hear the last part of the question. Just repeat that.
AWS Fargate, Kubernetes, Docker solution from AWS.
Yeah.
Why don't you use that instead of?
Yeah, I mean, in the end, whatever floats your boat, bro, right? So, I mean, if you feel as if something will solve your issue, go for it. I personally, I haven't tried Fargate. I've tried pretty much anything except for Fargate. But from what I know, I've used Lambda a lot. So AWS Lambda, the serverless functions, it's the same concept. It's just a simple difference of deploying the container into the serverless environment versus deploying the code in Lambda to the serverless environment. I think it's awesome. I think it's awesome for some things, but you maybe wouldn't want to run that as your core service in your product, because whenever something is very database intensive, has a lot of communication with the database, using serverless sucks. It's like through and through sucks. If you're using serverless for something that's not going to have that many interactions with a database, just awesome. So if you have a core service that's running on your own Kubernetes cluster, wow, it can be whatever, and you're using Fargate for external services that are going to communicate with that cluster, that's amazing. But if you're using Fargate to communicate directly with the database, just don't.
Thank you.
More questions? No?
Do you have any, thanks for your awesome talk, by the way. Do you have any tips on like Nginx ingress? Like, could it be a bottleneck? Does it run on a container, or how does it?
Well, to be honest, first of all, this is an intermediate level talk. I didn't want to go into the details of ingress. Ingress is a Kubernetes resource called a daemon set.
Okay.
That is basically quite literally a pod, but it's deployed into the cluster as a daemon, meaning that every node will have one.
Awesome.
Okay. But not to like confuse everybody here,
what?
Because we're wearing the same shirts, we'll have a beer, and I'll explain.
Okay.
Okay. If anybody wants
so
to know,
so
like,
it cannot become a bottleneck because it runs on every node, and therefore beer. Okay.
I'll have another question. You can also use an external load balancer outside of your. No. I can just to explain this. You can use an external load balancer outside of your cluster as well. I mean, if you're running on AWS, like 95% of people here and 100% of normal people would. And I just remember this is recorded. Anyhow, the external load balancer, you can use ELB on AWS or whatever. So that is going to route your, resolve your DNS and all those crazy complicated things that most of us don't understand but still use. And then use that as an external load balancer, and then does it. Then you don't need the ingress. You can still use it, but you don't need it, right? Yep.
Further questions?
You can also grab me after this at the beer thing.
Yeah. If not, thank you, Adnan. And I invite you to stick around for the closing word. Thanks.